This is a review for the 9.1 through 9.5 test. Numbers 1 through 8, we're multiplying and dividing monomials. So on number 1, we need to focus on multiplying the same types of the parts of these two monomials, which means we're going to multiply one coefficient times the other coefficient. Negative 11 times 3 gives us negative 33. Then we want to multiply the a's together. A times a to the third. We said anytime we multiply a variable times the same variable, we do that by adding the exponents. So a to the first times a to the third is going to give us a to the fourth. And then we are going to multiply the b's times the b's. B to the first times b to the fourth, again a b times a b. We add the exponents. That's going to give us b to the fifth. And then finally we have this c that doesn't match up with any other c's, so we'll just bring that down to where all of these are multiplied by each other. So our final answer would be negative 33 a to the fourth, b to the fifth, c. We know that our answer is in simplest form if we don't have any fractions that can be simplified, if we don't have any negative exponents or any other operations that we can perform in the problem. On number 2, same thing. We have a monomial times another monomial, but now we're going to be seeing this exponent on the outside. So if we're ever confused as to where to start, just like with anything since middle school, we want to consider the order of operations. Are there anything inside of the parentheses, any operations that we can perform inside the parentheses? Negative 4 a to the fifth, nothing that can be really done there. Same thing with these parentheses, negative 3 times b, nothing that can be rewritten in a different way. So we don't really have anything inside the parentheses to do. Any exponents? Well, we see an exponent on the outside of the second monomial that we can apply to both parts of the monomial, the coefficient and the b. So when we've done that, negative 3 to the second power is going to give us positive 9. Be reminded that negative 3 to the second power means negative 3 times negative 3, which is positive 9. If we enter that in the calculator, we have to enter that as negative 3 squared. If we type that in without the parentheses, it's going to give us negative 9. B to the first raised to the second power is going to be b squared. So be reminded, if we're raising an exponent to another exponent or a power to another power, we multiply the exponents. So we end up with 9b squared. The first part of this expression that we haven't done anything with yet, I'm just going to bring down and make it negative 4a to the fifth. So we've done all operations we can with our exponents. We still have some exponents, but nothing can be really simplified with them. So any multiplication or division, well, yeah, we see that one of these monomials is multiplied by the other. So just like on number 1, we'll multiply the coefficients. When we've done that, that gives us negative 36. We'll multiply the a's. There aren't any a's to multiply them with, so let's just bring a to the fifth down. And then b squared. There's nothing to multiply that b with because there aren't any other b's, so we'll just bring that down as b to the second power. So this would be our final answer on number 2 in simplest form. Number 3, now we have a monomial raised to the second power. We want to see, just like on the last problem, are there any operations that can be performed inside the parentheses? Nothing can be really simplified at all inside of there. Any exponents that we can do simplify in any way? Well, we have an exponent on the outside. This exponent of 2 can be applied to the coefficient of 4/9 and to the d to the third power. So 4 to the 9th power, or 4 over 9 to the second power is going to give us 16 over 81. If we're unsure of how to do that, well, it's just the numerator is squared and the denominator is squared. But if we ever get to that point on a test and we're still confused with how to enter 4/9 to the second power, let's just use the calculator. I'm going to, in parentheses, I'm going to enter 4/9 raised to the second power. When we hit enter, we get a decimal. I don't want to leave our answer as a decimal because we started with a fraction, so we'll hit the math button and choose the first option that says fraction and hit enter. When we've done that, we get 16 over 81. And then d to the third is raised to the second power. It's a power raised to another power, so we multiply the exponents. When we've done that, we're going to get d to the sixth power. So that's our exponents. Any multiplication or division, we'll know 16 over 81 is multiplied by d to the sixth, but nothing can be really simplified with it. There's no division in the problem. We don't see any addition or subtraction, so we know that this is our our answer in simplest form. Number 4, now we're starting to deal with the division of monomials. The way that I've recommended handling these is to always consider whether or not we can simplify anything individually on top or on bottom of the fraction. When we look at number 4, there's nothing that can be really simplified on top. We just have 8m to the 6th. If we look on the bottom, there's nothing to really be simplified on the bottom either. So we're ready to start treating it as this big division problem that it is on number 4. So the first step we want to take is to simplify the coefficients, the fraction 8 over 24. Again, if I'm unsure of how to do that, I can type it into the calculator and get as a decimal 8 divided by 24. We can get 0.3 repeating. If we want to change that to a fraction, math, fraction, enter, we get 1/3. So on top 1, on bottom 3, but then we have some m's that we can divide. The way we divide variables is to subtract their exponents. So since we have m's on top and bottom, I'm thinking about moving the m on the bottom up to the top so that we can subtract their exponents. That's going to give us m to the 6 minus 1. We're always asking ourselves the question, can we clean up the top any? Can we clean up the bottom any from the way that it's written right now? Well, on top we have some exponents that can be subtracted. So that's going to give us 1m to the positive 5th. On bottom we still just have a 3. Alright, is there anything else that we can clean up? Well, yeah, we don't have to have a coefficient of 1, so I'm just going to leave that coefficient of 1 off. So we've divided everything there is to divide. We reduced the fraction to 1 over 3. And it looks like this is in simplest form. We know it's in simplest form because the fraction's been reduced. Our variables that we had on top and bottom are now just in one spot, just on top after we divided, and we don't have any negative exponents. So number 4, that would be our answer in simplest form. Number 5, well, this is the same type of problem from number 4, but now it looks a little bit more complex. We have more variables and exponents to deal with. Same process though. We want to see, is there anything that we can simplify just on top the way that it's written right now? There's not really any way that we can write that in a different way, so the answer to that is no. Then if we look at just the bottom, there's nothing that we can simplify just on bottom. So now we're ready to start treating this as a big division problem. I want to divide the parts so that are the same types of parts. I want to divide the coefficients, 24 over 9. If we're doing that by hand, we want to see if there's a common denominator, if there's anything that will go into both of those evenly. If I'm unsure of how to do that, then there's no sense in us missing that basic step at this point. So I'm going to type in 24 divided by 9, which is going to give us 2.6 repeating. We need to get that as a fraction, so we're going to hit math, choose fraction, and enter. That gives us the fraction of 8/3. So on the top of our fraction we're going to have an 8. On the bottom we have a 3. Just like on the last problem, we have a's on top and bottom, so we need to divide those. The way we divide variables is to subtract their exponents. So collect all those to one spot, move the a's to the top, and then write that as a to the 4 minus 3. The b's, well, we only have b's on top, so there's nothing to divide the b to the 6 by, so we'll just keep that on the top as b to the 6. And then the c's, we have c's on top and bottom, so we'll always move the one on the bottom up to the top and subtract the exponents. So c to the 6 minus 12. Always, always, always trying to clean up the top and clean up the bottom before we move to the next step. So on top we can rewrite that as 8a to the 1st, b to the 6th, c to the negative 6th. On bottom we have a 3. So we've divided everything we can divide. It looks like we're in pretty good shape except for one thing. We said that if we ever have a negative exponent, then we need to do something about that. If it's a negative on top, then we can move that variable and its exponent to the bottom and change the sign. So what we have remaining on top is 8a to the 1st, b to the 6th. On the bottom we still have our 3, but now we also have a c to the positive 6 that joins it. The only other thing that we can write in a little bit more reduced of a way is I'm going to leave the 1 off as an exponent to where our answer looks like this. Looking at number 6, again, same type of problem. We have a monomial divided by another. I want to clean up the top or bottom as much as possible before we start dividing things. So when we look on the top half of this fraction in the numerator, there aren't really any operations that we can perform as it's written right now. We could move the variables and their exponents to the bottom to handle their the fact that they're negative, but a lot of times if we just end up dividing the variables like we're going to need to here, the negative exponents will kind of take care of themselves. So nothing to do on top. If we look at the bottom though, there is an operation that we can perform. We have this monomial raised to the power of -1. So if we apply that to both parts of that monomial, then on the bottom half in the denominator we're going to end up with r to the -3rd, s to the -6th. A power raised to a power we multiply. 3 times -1 is -3. 6 times -1 is -6. So on top we still have that monomial that we started with, r to the -4th, s to the -3rd. So we cleaned up as much as we could on the bottom, and now we're ready to start dividing the parts that are the same types of parts. So since we have r's on top and bottom, let's move the r's on the bottom to the top and subtract their exponents. Same thing with the s's. S's on top and bottom, move the s's to the top and subtract the exponents. So what we have on top now is going to be r to the -4th minus -3. We also have s to the -3rd minus -6. If I had to make a guess as to where somebody's going to mess up, it's going to be -4. Somebody's going to want to do -4 minus 3, -3 minus -6. But it's always top minus bottom, so -4 minus -3. We moved everything from the bottom of the fraction up to the top, so we need to fill that space with something. So for right now, let's fill that with a 1 since there's nothing there right now. Now we can subtract the exponents in our numerator. R to the -4th minus -3. Well, -4 minus -3 is -1, so r to the -1st. And then our s's, -3 minus -6 is +3 over 1. Again, we have a negative exponent in this problem, which we can't leave in that form, so we're going to move r and its exponent to the bottom and change the sign of the exponent. So what we have remaining on top is s to the 3rd. What we have on bottom is 1 r to the +1st. And then we're going to clean that up as much as we can. If we have an exponent of 1, there's no point in having it, so let's just leave that off. And if we have a coefficient of 1, we can leave that off. So our final answer is just going to be s cubed over r. Looking at number 7, again I want to treat this as two separate parts to start off with. I want to look at the numerator individually and then the denominator individually before we start dividing the top and the bottom. So on top, it looks like we have a monomial raised to the 3rd power and then multiplied by the second monomial. We always want to follow the order of operations, so I always do want to check to see, can we do anything inside the parentheses, either this set or this set? Well, there isn't really anything that we can do or simplify inside of there. So parentheses, we're good. Any exponents up top that we can apply? Well, we have this exponent of a 3 outside these parentheses, which means that it is going to be applied to the 2, to the x, and to the y cubed. So when we perform that operation on top, we're going to have 8, that's 2 times 2 times 2, x to the 3rd, y to the 9th. And then the first monomial is going to be multiplied by -4 xy. So parentheses, we didn't have any to take care of. Exponents, took care of that with applying the 3. Any multiplication or division on top that we can perform. Well, yeah, this first monomial is multiplied by the second. So let's simplify that by saying 8 times -4 gives us -32. X cubed times x, we're going to add the exponents to get x to the 4th. Y to the 9th times y, we're going to add the exponents to get y to the 10th. So now the numerator is in the simplest form possible, And now I want to uncover the denominator and see what we have underneath there. Well, on the denominator, there's not really any operations to perform, so let's just write it underneath our simplified numerator, 24x to the 7th y squared. At this point, now we want to start treating it as a division problem. We wanted to reduce the coefficients that are written as a fraction. So negative 32 over 24. Again, if I'm searching for a common denominator and I can't come up with it, then we can always find that with our calculator by treating that as by finding the quotient of those two. So I'm going to type in negative 32 divided by 24. When we've done that, and hit enter, we get negative 1.3 repeating. Well, if we want that as a fraction, math, fraction, enter, we get negative 4/3. So on the top of our fraction, we're going to have negative 4. On the bottom of our fraction, we get a 3. We have x's on top and bottom. We said if it's in simplest form, that can't be true. So let's move the x's on the bottom to the top and subtract the exponents. So x to the 4 minus 7. Same thing with the y's. If we have y's on top and bottom, we need to move the y's to the top and subtract the exponents. So y to the 10 minus 2. So if we simplify the numerator now, that would give us negative 4x to the negative 3rd, y to the 8th over 3. Looks like it's in pretty good shape except for one thing. We said that we can't leave a negative exponent as part of our answer, so let's move the x and the negative 3 to the denominator and change the sign. So what we have remaining on top is negative 4, y to the 8th, and on bottom we have 3x, and now our exponent changes from negative 3 to positive 3. So that would be our answer in simplest form. And then number 8. Number 8, I want to treat it exactly like the last one. I want to check and see if on the bottom or top of this fraction we can simplify anything before we start dividing anything. So on top we see a monomial times another monomial. So the first step we would need to take is to multiply 3 times 5 to give us 15, a times a to the 3rd to give us a to the 4th, and b times b to the 4th to give us b to the 5th. If we uncover the bottom of that fraction, it says 9a to the 7th b. Well, there's nothing to really simplify with the bottom, so let's just bring it over. Now that we've simplified the top and the bottom as much as we can, now we're ready to start dividing the like parts. So 15 over 9, those coefficients can reduce, and that would give us 5 over 3. We have a's on top and bottom, so let's move the a's on the bottom up to the top and subtract the exponent, so a to the 4 minus 7. Same thing with the b's. B's on top and bottom, shift the b's up and subtract the exponent, so b to the 5 minus 1. When we clean up the top of that fraction, we'll end up with 5a to the negative 3rd, b to the 4th. On the bottom, we still just have a 3. We're in pretty good shape, except that we can't have a negative exponent as part of our simplest form answer, so we'll move the a to the negative 3rd to the denominator of the fraction and change its sign. So what we have remaining on top is 5b to the 4th. On bottom, we have 3a to the 3rd. This is in simplest form because we know that the coefficients have been reduced. All of our a's are in one spot. Our b's are only in one spot from where they were in multiple places at the beginning of our problem. And we know that we have no negative exponents. So that's just a checklist we need to go through in our heads before we call it quits on any problem. All right, the next section, we are looking at finding the sum or difference of polynomials. So we're adding or subtracting. A recommendation that I gave in class yesterday was that instead of looking at this as one big horizontal problem, all from left to right, I want to rearrange these types of problems to where we are stacking like terms right above each other. So since this is a subtraction problem, I want to bring my minus sign down here, and I want to line up the two x's underneath the x's, so 2x. I want to line up the y's underneath the y's, so plus 8y. I'm keeping the sign that comes in front of the 8y. Recommendation I gave in class just to make sure that people are paying close attention to the type of sign that we're dealing with, whether it's plus or minus. I said if we ever have a minus sign, let's change it to addition and add the opposite. So negative 2x minus 8y. I've just found with that, if we make that small change, then people are a lot more likely to pay attention to the signs that we're seeing in the problem. So 5x plus negative 2x is going to give us 3x. 6y plus negative 8y is going to give us negative 2y. This is in simplest form because these are not like terms, so they can't be subtracted. This is going to be the the farthest that we can reduce anything there. Looking at number 10. Now we have an addition problem. We're adding one polynomial plus another polynomial. So I'm going to bring the plus sign down underneath the first polynomial, and then I'm going to stack the like terms one right above the other. So I want to put the 2a underneath the other a. So down here, 2a. Put the plus 5m underneath the 5m, or underneath the m in the first polynomial. So plus 5m. We know that we are adding all of the coefficients now of all of the like terms. 5 plus 2 gives us 7, and we're going to keep our variable a. Negative 6 plus 5 is negative 1, so minus 1m. Only other thing that will change on number 10 is if we have a coefficient of 1, let's just leave it off to write it as 7a minus m. On number 11, now we're adding a polynomial and another polynomial, but we have kind of an unequal number of terms in each polynomial. So I'm going to still stack as many of the like terms on top of each other as we can. So since this is an addition problem, I'll bring the plus sign down here. The 3x squared I want to put underneath the x squared, so 3x squared. The 8x I want to put underneath the x's. Well, if we look over here, there aren't really any x's. So what I'm going to do is really small in here, I want to squeeze in plus 0x. If there aren't any x's in number 11 in the first polynomial, it's like you have a 0x. So I'm going to write plus 8x right underneath the plus 0x. Then plus 4. I'm going to stack underneath the other constant, just the minus 4. All right, we're adding in this problem, so I just want to add all the coefficients. 5 plus 3 is 8, so 8x squared. 0x plus 8x is going to be 8x. Negative 4 plus 4 gives us 0, so plus 0. Well, we know that if we have plus 0, it's just like having nothing, so let's just leave that off, and we can express that in simplest form as 8x squared plus 8x. Number 12 is a subtraction problem, so we want to bring our subtraction sign down here and then stack the like terms. 2x squared, y squared. We can put that directly underneath the x squared, y squared down here. 2x squared, y squared. Plus 2xy. Let's put those underneath the xy's, so plus 2xy. Plus 3. Let's put it underneath the other constant. We're subtracting these polynomials. So the way that I recommend that you do this, again, is to change the subtraction to addition, and we're going to add the opposite of each of these. So 3x squared y squared plus negative 2x squared y squared would be 1x squared y squared. Again, we're going to keep the variables and their exponents exactly like they were before we added them when we're adding or subtracting polynomials. Negative 3xy plus negative 2xy is going to be negative 5xy, so we'll write that as minus 5xy. And then negative 7 plus negative 3 is negative 10. None of these are like terms, so we could say that this is in simplest form on number 12. On number 13, we have an addition problem, so I want to bring the plus sign down underneath the first polynomial and then stack the like terms. 5a squared I want to stack underneath the other a squared. Well, we don't have any a squareds in the first polynomial, so let's just write it over here to the left. I want to stack the 8a underneath the other a, so plus 8a. Minus 11, stack underneath the other constant of negative 7, so minus 11. All we're doing here is adding, so we want to add the coefficients. 5a squared, there's nothing to add that to, so just bring it down, 5a squared. 2 plus 8 gives us 10, so 10a's. Negative 7 plus negative 11 is negative 18. None of these are like terms, so we know that that's in simplest form. Alright, and then number 14, this is the last one that we'll do. We did all of the, or most of the review problems together today in class. So looking at 14, this is a monomial minus a binomial. We can handle this exactly like we have the others. I want to bring the minus sign down below, and then I want to stack the 8r underneath the r's. If we don't have any r's, then I'll just write it over here to the left, 8r. Plus 5p, stack that underneath the p's, so plus 5p. This is a subtraction problem, so we've looked at that as the opposite of addition, or adding the opposite of something. So we're going to change this to plus negative 8 minus 5p. So with the 8r's, there's nothing to combine that with, so we'll just bring down negative 8r. 6p plus negative 5p is going to be positive 1p, so plus 1p, and the only other thing that I would change with that is to leave off that coefficient of 1 and just write it as negative 8r plus p. Alright, y'all, I hope this helped you.